Good morning to one and all. Myself, Dr. Ganesh. I am working in MLR IT in C department. I am going to be discuss the subject in signals and systems, and in which the first lecture is in the introduction to the signals. In overview, we will discuss introduction to the signals, in which one is characteristics of the signal here. And in this portion, we will going to be cover these three parameters. It is one is the amplitude, and the second one it is bandwidth, and third one is randomness. After that, we are going to be discuss about the classification of the signals. So, in introduction to signals, so the main definition of the signals and systems, the first we will discuss with the what is mean by signals, and the second one it is what is mean by the systems. In the first portions, we are going to be discuss what is mean by the signal in general. So, in general, the signal is nothing but which carries the information. Signal is carries the information. It's a physical quantity which varies with respect to time t. In general definition, we can write it is a representation of a physical quantity and varies with respect to any dependent variable or independent variables. One is a dependent variable and the independent variables. See, right? Another way we can define it is a signal is a single valued function which carries the information by means of frequency and phase. So it varies with respect to the frequency and phase. So if we discuss the signal, simply it's a information. Signal is generally it is a information, and it varies with respect to the independent variable or dependent variable. So generally we are saying it is information that carries the information in terms of electrical way, or you can see, or suppose if I take one signal which respect to time t, and I have named the signal it is x of t. So at the time t, the signal value it is 0, and for suppose if I take it as an example, take the cricket. If I take the cricket in the first over, so in the 0th over there is no ball and there is no runs. I am taking it is a balls. It is a runs. In first over, 0th over 0 ball, and if I take it as a first over, I scored around it is 5 runs, and in second over I scored around it is 5 runs, and third over I scored it is 2, and it is 4. In fourth over I scored it is 10, and fifth over I scored it is a, let us take it as a 20. Now this is the information. This information we are going to be represent in the signal format. So the same information we need to represent in a signal format. Look at here. I am taking on two-dimensional Cartesian space. It is, let's take it is a time t. In general, it is time t. Now x of t. This is a signal representation. But in our example, this time it is a balls. You can call it as a overs. You can call it as a balls. And the x of t, it is a number of runs scored by the batsman. So it is 0, no, and we have the how many overs? We have 5 overs. It is first one, first over, second over, third over, fourth over, fifth over. So right, I am writing this. These are the some values. It is 0. Let us take it as a 5, 10. It is 15. Now it is a 20. Now in this case, I look at here at 0th over, there is no score at us. At the first over, how many runs I got? It is in first over, I got the 5 runs. It is means at this position, I got it. And in the second over, you can see it is I got in second over, same, I got the 5 runs. It is one more thing. It is at the third over. At third over, I got it is how many third over? 2 runs only. In between like this one, this line, you will get this is the second, 2 runs it is. In fourth over, I got 10 runs. And this line it is, you can take it as a 10 lines, and it is a fifth over. In fifth over I got the 20 runs. It is approximately like this point it is fifth over. So this is the runs. So if I connect these all dots, it is a signal. So which signal it is? It is a cricket score signal for the first 5 overs. 5 overs. So what is the definition of the signal? A signal which carries the information and which must be varies with respect to one variable, any other dependent variable. That variable must be time, or here it is we have the, if we take it as in time domain, it is t, and in general in our example we are taking it as a number of balls. at first over and second over, third over, fourth over, fifth over, and the signal is varying like this. So does this, if I given the same graph to you, if I mention it is a number of balls, I mention if it is a number of balls and these are the runs. One can easily understand if I given this graph to you, then you can simply say at first over 0 runs and second over you got the 5 runs, and it is a third second over 5 runs it is, and third over 2 runs like this. So this is called the signal. So signal means which carries the information and varies with respect to time t or any independent variables or even dependent variables also. Right. Next, what are the main characteristics of the signals? So what are the characteristics? Characteristics of the signal. First one I mentioned it is amplitude, and second one is a bandwidth, and third one it is a randomness. See, if I look into the first one, what is mean by amplitude? Amplitude means it is a physical quantity, it is produced by the particular signal. You can call it as a height of the signal or strength of the signal. In the same example, I mentioned it is at first over it is 0, first over 0, and the second over it is a 5 runs I mentioned, and in the third over also I mentioned 5 runs, and fifth over it, fourth over it is 2 runs, remaining it is a 20 runs. One is a 10 runs is there in between. So this is the amplitude is nothing but the physical quantity. That means whenever we are throwing the ball and that batsman hit the ball and it will reach us to some location and we gain some points. That height we are representing with respect to 0. In this one it is first over he got the 5 runs. That means the height from the 0 to either 0 or 1 or 2 or 3, 4 and 4 up to maximum you will have the 6 runs. So in that case for one ball it is maximum 6 runs. So but in complete 1 over he got the 5 runs. That means this is a height of the signal, and that particular time position it is a height of the signal, that is called the amplitude, height, or you can call it as a strength also, height or strength also, you can call it as a height and strength. Bandwidth means it is a when you are in particular single domain, it is if it is in, let us take it is in time domain, the same signal will occupies in frequency domain in a different way. The same signal will occupies the its same characteristics in frequency domain in different way. I will take the another example to define the bandwidth. If let us take this is some cotton. Let us take it as a 1 kg of cotton. 1 kg of cotton we will have. So if I say this cotton has the volume. So in this domain, so if I see the raw material, in this raw material I know the parameters, it is weight is 1 kg, and its volume whatever the volume it is, let us take it as a x, volume is there. So if I ask the one question, for this same cotton, can you tell me the one thing, it is if I am taking a thread size with a 1 mm, we are going to be generate the threads by the cotton only, right? So I am asking the question, how much length of the thread generated by this cotton? So can you tell me in this position directly? No, it is not possible. By seeing the cotton you cannot say, but you can say the same with this diameter. I can produce the some length of the thread by converting this cotton to thread. So let us take this is a thread, our required thread, whatever the diameter I mentioned it is 1 mm. So whatever the diameter as I mentioned it is a 1 mm. Let us take 100, let us take 1000 meters. 1000 meters of thread is generated. The question is here, in raw domain, that means when it is in a carton format, you cannot say how much length of the thread is generated. So this is, if I ask the same question at this position, at this position you cannot say. That's why I am transforming this raw material into the, let us take it as a transform. I am transforming this raw material into the thread. So I am transforming into the thread so that I can able to find the what is the length of the particular thread. But one more thing, whatever the weight is there, 1 kg weight of this thread, also same, this thread also has the 1 kg. That means weight is not going to be changed at all. And only 2 parameters. In this one, volume you are saying it is a some x volume is there, and here we are taking it is a 100 meters length of thread, so that we are getting the length of the thread. So similarly, x of t is a time domain signal. The same signal we will have the amplitude in time domain and time period in time domain. These 2 parameters we will find in a time domain. But the same signal, if we converted into the frequency domain, the same signal now which is in frequency, not in time. So same, let us take x of f, which is in the form of f. The signal is in different format. The signal will occupy the different format. Here it is, we will have the from 0 to, let us take it as a 100 hedges. So in between the 0 to 100 hedges, this signal is occupied in frequency. So the bandwidth of the signal which means where the signal exists in a frequency domain, from where to where. That means it is in the 0 hedges to 100 hedges. This distance, this width, that means 100 minus 0, you can call it as a 100 hedges. This is a bandwidth of the signal. Understood? So amplitude is generally we can call it as a height or strength, and bandwidth I mentioned frequency ranges of the signal in frequency domain. See example, one more example I can say. Suppose x1 of t is a signal and varies with respect to time t, and this is from 0. Let us take this is a signal, and I converted this signal into the frequency domain, and I converted the same signal into frequency domain. The signal is occupies like this. This is in f domain, that we can call it as a frequency domain, x of f. Now the signal varies from the, let us take it as a 100, 1100. So 100 hedges to f is in terms of hedges. So 100 hedges to 1000 hedges. Then what is the bandwidth of the signal? The definition of the frequency range of the signal in frequency domain. So this is the x of done. What is the range? It is 100 to, it is 1100 hedges. That means what is the bandwidth? It's a difference between 1100 minus 100 means 1. 1100 means 100. It is a 1000 hedges. Okay, this is called the frequency. So if it is start from the 0, then we will subtract from the 0 to 1000. So 1000 minus 0, you will get the frequency. It is a 100 Hz. This is about the bandwidth. Now coming to the next one, randomness. Randomness means, for suppose the signal starts from the here at 0, and at 0 position I know present. I am calling it as a present time. At present time I know the output of the amplitude of the signal is 0, and what is the next output? So let us take, I am taking it as a, at time t is equals to 1 second. At the 1 second, do I know the output of the signal? If it is no, if it is known thing, it is not the randomness. It must be random value, random variable. You can call must be, it is a random variable. Simply I can say in cricket terms, it is in first ball I made it is a 5 runs. Do I know the exactly what is the next score of the second ball? Second ball, first ball it is 5 runs. I mean 4 runs I made it 4 runs. So I don't know whether I will beat it the second ball or not. That is a unknown thing. It is quite it's not known thing, so that is called the randomness. Unknown value, future value we cannot expect. The situation where we cannot expect the future value, it is known as the randomness. So this is the randomness. That means the future value is unknown. The future value is unknown. That means if any physical quantity has the amplitude, second one it is a bandwidth, third one it is a randomness. So now the definition of the signal varies in a different way. First one, which carries the information. Second one, it is a single valued function, carries the information. It's a single valued function which carries the information. And third one, you can say any physical quantity which satisfies these three conditions, also we know it as a signal. That means obviously if any physical quantity satisfies these three parameters, amplitude, bandwidth and randomness, and this is also called as a signal. If any physical quantity satisfies the three following parameters, then this is also called as a signal. Understood? Amplitude is a height of the signal, or you can call it as a strength of the signal. Bandwidth means width of the signal in frequency domain. And the randomness, it is the future value of the signal, it is unpredictable. That is the three statements blindly, right? Now you look into the definition I already given. Let us consider the real valued real time signals. What are some examples? Voice signal. My voice is raising. That means at particular time my signal strength is very weak, like this. And at particular time my signal strength, when I am speaking loudly, the signal strength is very high. And at one particular point medium, and particular point it is slow. So that means like this is a voice signal. But like in a video signals also, some of the examples. Now one more thing, we will see that in a mathematical way. See, x of t is a signal. X of t is a sin omega t plus phi, and this is a signal, and we are drawing the signal like this. This is a time t, and a signal name, it is I mentioned it is a x of t. See, what is the information is carrying in this, in this signal, we don't know. Whether if it is given it, then we can understand what kind of signal. So for this one, we can say it's varying with respect to time t. So it is varying with respect to time t, and its amplitude is x of t. So amplitude is x of t is given. In this one, we have the two signals. One is a blue line, first one. Second one, it is a yellow line, it is a second one. Two signals we will have. But the mathematical representation for these two signals are similar. It is only a sin omega t plus phi. But where is the main difference? That means it is a phi is the difference. Phi is the difference. That is the phase difference between these two signals. The phase difference between these two signals. Before going to that, what is the amplitude of this one? You can call it as a height of the signal. It is amplitude. Amplitude is here. It is, if it is multiplied by some factor, it is that factor. That means here it is amplitude is a. If a is not there, by default it is a 1. So if it is plus a and it's a lower one, it is a minus a. The what is now, we can call it one term, peak to peak amplitude. A means high peak it is a, and low peak it is also a, but it is, since it is a negative, we are calling it as a minus a. When I said it is a peak to peak amplitude 5 amps means, I mentioned it is 5 amps is the maximum value for a sine signal, and 5 amps it is a minimum value for the sine signals. So it is about the peak to peak amplitude, you can call it as a peak to peak amplitude. Right. The next one, it is a omega. Omega is equals to 2 pi f. It is a angular frequency. Next one, it is a omega. It is a angular frequency 2 pi f. This f is in frequency domain. This f is in frequency domain. If you convert this signal into the frequency domain, you will get it's a frequency domain representation. That parameter we are representing it as a 2 pi f. It is angular frequency. So f is equals to 2 pi. F is equals to frequency, that is equals to 1 by t. F is equals to frequency, that is equals to 1 by t, means it's a time period. what is time period? Here it is one term. If I draw a sine wave, this is a sine wave. So if you look at what is the time period of the signal? So see, this is a positive wave, positive half cycle, and this is a negative half cycle. And the same positive cycle is repeating here. Same positive cycle, it is repeating here. So this is a negative and this is a negative. As usual, it is a t and this is a x of t. Now, what is the time period? If you look into this one, in between this duration, the same signal is repeating. If you look at this one, same signal is repeating like this. A periodic signal with a time t, fundamental time period, this portion is going to be repeated infinity number of times like this. So, the unique portion whatever is going to be repeated n number of times or infinity number of times, that period is known as the fundamental time period. Fundamental time period means the period of the unique signal. I mentioned the term, it is unique signal. The period of the unique signal which is repeating n number of times or infinity number of times is known as the fundamental time period. So, if you reciprocate it as a need to find the frequency, that is called generally it is a time period. F is equals to 1 by t. So, by using this formula, we are going to find the frequency of the signal at that particular position, right? Coming to here, in example, we will see the sine wave signal, and this is a phase difference. This is a phase difference, you can call it as a, though this one is amplitude, I mentioned clearly, amplitude, this is, and this one is the phase. So, if you look at what is the phase difference between the wave 1 and wave 2, I can say simply sine 0 is 0, sine 180 is 0. You look at here, these two terms, sine 0 is 0, sine 180 is also 0, sine 90 it is 1. Let us take 180, how many portions are there? 1, 2, 3, 4, 5, 6. 6 parts are divided. For 6 parts, 180 degrees. Now, how many parts are there? For one part? For one part, how many parts it is occupied? 1, 2. In between this 1 and 2, 2 parts are there. For 2 parts, it is, for 1 part it is 30 and it is 60 for 2 parts. Okay. For 1 it is 3, oh correct, 60 parts. That means phi is equals to 60 degrees. Phi is equals to 60 degrees. This portion it is 60 degrees. Phi value. That means phase difference. The phase difference between these two signals is 60. Okay, this is about the what is mean by signal. Now coming to the next one. So, classification of the signal. In classification of the signal, we can say there are n-dimensional signals are there, and based on the dimensionality. As I mentioned, the signal varies with respect to time t or some any other parameter, or we can call it as a dependent variables or independent variables. So, that number of dependent or independent variables defines the dimension of the signal. So, the number of variables defines the dimension of the signal. If that particular parameter is only 1, that is a one-dimensional signal. If it is 2, two-dimensional signal. 3, it is 3-dimension. You can call it as, if it is multi, you can call it as a multi-dimensional signal, right? One-dimensional means if the signal is a function of only one variable, or if a signal value varies with respect to only one variable, then it is called as a one-dimensional signal. You look at here in this one. First one, this one is a ECG signal. So, ECG signal, this value is varying with respect to only time variable. This is time t. So, there is no other variable. And the same here also, same signal with respect to time t in hours. They mention it is clearly, it is hours. Now, in y-axis, they mention it is a temperature in degrees centigrade. And one more thing, he is given the 3 materials. It is, one is a glass, and second one it is a foil, and the third one it is a silver. Okay, so this is at 8, and this is at 10. If I take let us take it at 12 o'clock. At 12 o'clock, if I look at here, and glass generated. So generally, the signal definition is nothing but which gives the information. So if what kind of information we are getting, and this particular date with respect to time t, at 12 o'clock, we will get the 3 temperatures for the 3 different materials. One is the first one, it is this one, second one, third one. If you draw that line to over here, you will get the temperatures. At 12 o'clock, for silver, you will have the 40 degrees centigrade. At foil, you will have the 45 degrees centigrade. At glass, you will have the 55 degree centigrades. So this is the information. And the thing is here, you have the multiple curves and multiple parameters, but these all multiple parameters all are varying with respect to time t only. Only one parameter is there. With respect to time t, this amplitudes, that means you can call it as the temperatures are varying. So that is called the one dimensional signal, because these all signals are varying with respect to one variable. Coming to the second one, this is the two dimensional variable. So two dimensional variable means if you take it as a Cartesian format with respect to pixels. For suppose this is a gray representation. Gray representation means, so to define the signal you need to give the white or black. These two colors you are going to be represent in this signal. So look at here, to represent the color for this particular position, this position we can call it as in image terminology pixel. So what is the pixel value? So this pixel value is going to be defined by the location. That means what is the location of this one? X value and Y value. So there is no time here. It is there is no time concept here. This is purely related to the two dimensions, that is independent variables X and Y. This X and Y, we are locating this point. For this point, if I given some particular color, so this point will be generated. To understand in a good way, I'll take the general example. See, X and Y. I'm taking 1, 1 point it is. That means it is a 1, 1. And I'm taking it's a 1, 2 point also. 1, 2. Next 2, 2. Next 1, 2. Something like this. If I take in like this. So these are the 4 dots. 4 pixels we'll have. If I consider these all points in between these 2 points, and if I consider all these 2 points in between this, and similarly in between these 2, similarly in this between 2. So what kind of message I am passing from this information? There is a square. There is a square representation in this one. So that is an image. So I am based on the 2 parameters X and Y. I am defining one message. It is a square message. This is a square symbol. I'm just processing to the square symbol by using the 2 parameters X and Y. Similarly, with the different colors, you can name it as you can define it as a color image also. This is a function of X and Y. This is also function of X and Y. And coming to the third one, 3-dimensional. The same signal, the 2-dimensional signal, if it varies with respect to time t. So in a particular time period, if you 24 frames are moved in a particular direction, then it will looks like a video. So that is called with respect to time t. X and Y are the same. And we are using another variable, it is a time. So with respect to time t, we are moving the images 24 frames per second. If you move like that, and that picture will be look like a video. That is called the video signal. So next one, types of the signals with respect to the nature. So as usual, if the signal time variable and x of t based on the single, I'm taking for the single variable, one dimensional signal. So if I consider 0 to infinity each and every point, that means I am taking it's a continuous, and this is a continuous. If I consider all points, that means from the 0 to infinity each and every time value, let us take it is 0 to 1, you need to consider infinity points in between 0 to 1. Similarly, 0 to 0.1 also you need to consider infinity points. Like that, if you find infinity number of time points in between any two adjacent points. That is called the continuity in time. So, two definitions. One is continuity in time means you are going to be considered 0. You are going to be considered 0, 0.0000000001 and 0.0002, like if it is possible 0 extends to the infinity also. That means you need to find infinity number of, so the signal is defining for infinity number of time samples, then that is called the time, continuity in time. So first one, it is a continuity in time. Continuity in time means you are going to be find the infinity number of time samples in between any two time samples. If I take these two time samples, you need to get infinity. If you get these two, and you need to get infinity time samples. So that is called the infinity time samples. So now continuous time signal means amplitude is defining for each and every time value. That too, the time values are infinity series. That means from the 0 to infinity, each and every time value is defined. So that is called the continuity signal. If a signal defined for a continuously from the 0 to infinity, at particular position at infinity, you may have 0 also amplitude. Amplitude 0 is also defined. It is amplitude 0. That means you will have the at particular time value, you have the specific value. This is one value and this is a one value. If I take at infinity, there might be 0. That is also defined. It is. That is a continuous in time. Next one, discrete. Discrete means we are not defining the infinity number of values in between any two adjacent values. Now here 0, 1, 2, 3, 4, so and so n. Now it is x of n. This is a x of t. At this position, I am defining at 0, I have amplitude is 2. At 1, I have amplitude it is 4, like 4, 2. This is 0. Let us take it as a 0. Now if you look into the x of n, the time amplitude, the signal amplitude is defined at only some specific position, not for the infinity samples. This is each and every line is there in between here. This is the continuity. But in coming to in this one, we are taking only specific, some discrete values only we are defining the amplitude. At 0, 1, 2, 3, 4, so and so for a integer values, we are defining the time value, amplitudes. So this signal is known as a discrete signal. Okay. Next, coming to the same signal, if the signal is defined for the continuous in time, the signal is also known as analog signal. Analog signal also. The same signal, if the signal is defined to the finite number of samples and these amplitudes are taking, it's a 2, 4, 4 and this one is 2, this one is 0, right? How many are there? 2 is defined, 4 is defined, next 0 is defined. So these are the three values are there. For digital signal, if I need to mention the digital signals, only two amplitudes. For digital signals, only two amplitudes. Only two amplitudes we are defining, either 1 or 0. So very clear data. If you define in general, digital signal is also a discrete signal. Digital signal also, it is a discrete signal. Why? We are defining n number of values in a discrete signal, that is 2, 4, 4 something, whatever it may be. But coming to the digital signal, we are defining same discrete number of sets only, discrete number of sets. But those discrete number of set values are fixed to the only two values, either it is 1 or 0. So these are the two values or the amplitude values. The time is always discrete. So these are the discrete signals. So thank you for this class. In what we studied in this class, one is introduction to the signals and the characteristics of the signals in which we are studied. One is amplitude and the second one it is a bandwidth and third one it is a randomness. And classification of the signals based on it is a continuous and analog, discrete, digital we have studied, and these are the things we covered in a present class. And the next class we are going to be studies about the representation of the continuous signal and the same representation of the discrete signals as well as, and what are the basic types of the signals are there. We will discuss it in the next class. Thank you.